We're going to work on an ALEKS problem that deals with using Henry's law to calculate the solubility of a gas. And Henry's law states that the solubility of a gas is directly proportional to the pressure of that gas. So what that means is, as I increase pressure, then I should have an increase in solubility. And if I decrease pressure of this gas, then I should also be decreasing the solubility of this gas. Let's take a look at an example. At 25 degrees Celsius, the Henry's law constant for sulfur hexafluoride gas in water is 2.4 times 10 to the negative 4 molarity per atm. Calculate the mass in grams of SF6 gas that can be dissolved in 1,100 milliliters of water at 25 degrees Celsius and a SF6 partial pressure of 2.15 atm. So as always, we want to start this off with our given table to make sure that we grab all the information we need. And the first thing they give us is Henry's law constant. And they're asking us to calculate the mass in grams of this gas. They give us the volume. And they give us the volume in milliliters, but I see that the constant has molarity in it. So molarity is moles over liters, so I want to make sure I convert my milliliters to liters. And they give us the pressure of this gas. So in order for me to find the grams of SF6, I'm going to have to do this in a couple of steps. The first thing I want to do is use Henry's law equation, which is the concentration of the gas is equal to Henry's law constant times the pressure of this gas. So I have the K, and I have the pressure. So my ATMs cancel out, so my concentration will be in molarity. So I'm going to go ahead and take this a step further and try to solve for the moles of my gas. So concentration is in molarity, so that's moles over liters. I have the concentration, and I have my volume in liters. So now I can go ahead and solve for moles. I want to make sure I put the whole unit. I know which gas we're talking about, SF6. Okay, so I have the moles, but I still need to get this to grams. So what I'm going to do is do a conversion. I'm going to go ahead and convert my moles to grams. Okay, I want to cancel out my moles of SF6, so I need to put that in the denominator. 1 moles of SF6 is equal to 146.049 grams of SF6. I want to make sure my final answer is in the correct sig figs. I take a look at my given table, and I see that the fewest sig figs I have is 2. So my final answer will also have 2 significant figures. So I have 0.083 grams of SF6. Let's take a look at another example. At 25 degrees Celsius, the Henry's law constant for CH4 gas is 1.4 times 10 to the negative 3 molarity per atm. Calculate the mass in grams of CH4 that can be dissolved in 925 milliliters of water at 25 degrees Celsius and a CH4 partial pressure of 2.03 atm. Now, as always, I always start off with my given table. I have my Henry's law constant. and they want us to solve for the mass in grams of CH4. They give us the volume, 925 milliliters, but since there is molarity in this unit, so molarity is moles over liters, I want to go ahead and convert milliliters to liters. And they give us the pressure of this gas. I want to start off with Henry's law equation, which is concentration is equal to the constant times the pressure. The ATMs cancel out, so my final answer will be in molarity. And concentration is in molarity, so that's just moles over liters. I can solve for moles of gas. Don't forget to use the liter and not the milliliter. And I don't shave off my numbers. I don't round to the very last step, so I don't lose anything. Okay, I've got my gas in moles, but I need to convert this to grams. Always start off with my given. If moles of CH4 needs to cancel out, then I got to put moles of CH4 in the denominator. 1 mole of CH4 is equal to 16.0410 grams of CH4. Take a look at my given table, and my fewest sig figs is going to be 2 sig figs, so my final answer is 0.042 grams of CH4. Good luck and keep practicing.